Today, we will explore the core and literally the star of the solar system, the Sun. We will also understand the important relation and connection of the Sun, the planets, and the Zodiac. There is only one important question. Are you ready, celestial explorers? The Sun is the star at the center of the solar system. It is a massive, perfect sphere of hot plasma, full and heated by nuclear fusion reactions in its core. It is the most important source of energy for life on Earth. As the Earth travels around the Sun appears to pass in front of a path full of constellations. The linear path that the Sun describes across the sky is called the ecliptic. The constellations on that path are collectively called the Zodiac and extend a few degrees above and below this line. The ecliptic is a line where the plane described by the Earth's orbit around the Sun crosses the celestial sphere. This is why the Zodiac is the region of the sky where we find the planets and the disk of our solar system. The Sun orbits the galactic center at a distance of 24,000 to 28,000 light years from Earth. It is about 8 light minutes away. About 150 million kilometers or 93 million miles is defined as the mean distance between the centers of the Sun and the Earth. Light travels from the Sun's horizon to Earth's horizon in about 8 minutes and 20 seconds, while light from the closest points of the Sun and Earth takes about 2 seconds less. The energy of this sunlight supports almost all life on Earth by photosynthesis and drives Earth's climate and weather. Its mass is about 330,000 times that of Earth. Roughly 3/4 of the Sun's mass consists of around 73% of hydrogen, and the rest is mostly helium, around 25%, with much smaller quantities of heavier elements, including oxygen, carbon, and iron. The Sun's original chemical composition was inherited from the interstellar medium out of which it formed. The hydrogen and most of the helium in the Sun would have been produced by Big Bang nucleosynthesis in the first 20 minutes of the universe, and the heavier elements were produced by previous generations of stars before the Sun was formed, and spread into the interstellar medium during the final stages of stellar life, and by events such as supernova. This magnificent star was formed approximately 6 billion years ago from the gravitational collapse of matter within a region of a large molecular cloud, and that probably gave birth to many other stars. It may have been triggered by shockwaves from one or more nearby supernovae. Studies of ancient meteorites reveal traces of stable daughter nuclei of short-lived isotopes, such as iron-60, that form only in exploding, short-lived stars. This indicates that one or more supernovae must have occurred near the location where the Sun formed. A shock wave from a nearby supernova would have triggered the formation of the Sun by compressing the matter within the molecular cloud and causing certain regions to collapse under their own gravity. As one fragment of the cloud collapsed, it also began to rotate due to conservation of angular momentum and heat up with the increasing pressure. Much of the mass became concentrated in the center, whereas the rest flattened out into a disk that would become the planets and other solar system bodies. Gravity and pressure within the core of the cloud generated a lot of heat as it accumulated more matter from the surrounding disk, eventually triggering nuclear fusion. Most of this matter gathered in the center, and the rest of it flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that it eventually initiated nuclear fusion in its core. Every second, the Sun's core fuses about 600 billion kilograms of hydrogen into helium and converts 4 billion kilograms of matter into energy. It has a magnitude estimated to be brighter than about 85% of the stars in the Milky Way, and it is more massive than 95% of the stars. The Sun is by far the brightest object in the Earth's sky. Since the Sun formed, the main fusion process has involved fusing hydrogen into helium. The amount of helium and its location within the Sun has gradually changed. and some of the heavy elements have settled from the photosphere toward the center of the sun because of gravity. The proportions of heavier elements are unchanged. The core of the sun extends from the center to about 20 to 25% of the solar radius. It has a density of up to about 150 times the density of water. Recent analysis favors the idea that the core is rotating faster than the radiative zone outside it. The core is the only region of the sun that produces an appreciable amount of thermal energy through fusion. The rest of the sun is heated by this energy as it is transferred outward through many successive layers, finally to the solar photosphere where it escapes into space through radiation, photons, or advection, massive particle. The large power output of the sun is mainly due to the huge size and density of its core. The visible surface of the sun, the photosphere, is the layer below which the sun becomes opaque to visible light. Photons produced in this layer escape the sun through the transparent solar atmosphere above it and become solar radiation, sunlight. The photosphere is tens to hundreds of kilometers thick and is slightly less opaque than air on Earth. The sun's atmosphere is composed of 5 layers: the photosphere, the chromosphere, the transition region, the corona, and the heliosphere. The coolest layer of the sun is a temperature minimum region extending to about 500 kilometers above the photosphere. This part of the sun is cool enough to allow for the existence of simple molecules such as carbon monoxide and water. The chromosphere, transition region, and corona are much hotter than the surface of the sun. Above the temperature minimum layer is a layer about 2,000 kilometers thick, dominated by a spectrum of emission and absorption lines. This layer is called the chromosphere from the Greek root chroma, meaning color, because the chromosphere is visible as a colored flash at the beginning and end of total solar eclipses. The temperature of the chromosphere increases gradually with altitude. Above the chromosphere, in a thin layer, about 200 kilometers, the transition region. The transition region does not occur at a well-defined altitude, but forms a kind of nimbus around chromospheric features such as spicules and filaments, and is in constant, chaotic motion. The transition region is not easily visible from Earth's surface, but is readily observable from space by instruments sensitive to extreme ultraviolet. The corona is the next layer of the sun. The corona is the extended atmosphere of the sun, which has a volume much larger than the volume enclosed by the sun's photosphere. A flow of plasma outward from the sun into interplanetary space is the solar wind. The heliosphere, the tenuous outermost atmosphere of the sun, is filled with solar wind plasma and is defined to begin at the distance where the flow of the solar wind becomes superalfinic. That is, where the flow becomes faster than the speed of alphen waves. Sunspots are visible as dark patches on the sun's photosphere and correspond to concentrations of magnetic field, where convective transport of heat is inhibited from the solar interior to the surface. As a result, sunspots are slightly cooler than the surrounding photosphere, so they appear dark. At a typical solar minimum, few sunspots are visible, and occasionally none can be seen at all. Those that do appear are at high solar latitudes. As the solar cycle progresses toward its maximum, sunspots tend to form closer to the solar equator, a phenomenon known as Spura's law. The largest sunspots can be tens of thousands of kilometers across. The Sun has 8 known planets orbiting it. This includes 4 terrestrial planets, which are Mercury, Venus, Earth, and Mars, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. The solar system also has 9 bodies generally considered as dwarf planets, and some more candidates, an asteroid belt, numerous comets, and a large number of icy bodies which lie beyond the orbit of Neptune. 6 of the planets and many smaller bodies also have their own natural satellites. In particular, the satellite systems of Jupiter, Saturn, and Uranus are in some ways like miniature versions of the Sun system. Now, it is time to explore the connection of the Sun and the Zodiac. If you like this video, support us by subscribing. It means the world for us, and it also allows us to keep creating content for you. The zodiac is the oldest known celestial coordinate system. As we saw in our previous season, the zodiac is divided into 12 equal parts, called signs, each occupying 30 degrees of celestial longitude. The signs are named after constellations that the sun passes through annually. The signs are Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. The sun has been an object of veneration in many cultures, and it has been a central subject for astronomical research since old times. It is connected with the zodiac because, in astrology, the zodiacal positions of the sun and the planets affect the outcome of events, such as someone's birth and personality. The sun's location relative to the zodiac changes because the Earth takes about 4 minutes longer to repoint towards the sun. The sun lags behind the stars, so it lags easterly every day by 4 minutes. It's been said that, like all stars, the sun will get to an end. Right now, it has approximately 120 million years of active life left. It means that is roughly halfway through the main sequence portion of its life. It has not changed dramatically in over 4 billion years and will remain fairly stable for about 5 billion more. However, after hydrogen fusion in its core has stopped, the sun will undergo dramatic changes, both internally and externally. About 4 to 7 billion years from now, when hydrogen fusion in the sun's core diminishes to the point where the sun is no longer in equilibrium, its core will undergo a marked increase in density and temperature, which will cause its outer layers to expand, eventually transforming the sun into full red. Thank you for watching.